Hi everybody, welcome again to my channel. Today we're gonna continue with that tutorial one, and we're gonna start with the pneumatical diagram of the stamper machine that we were proposing in the previous video. Um, I don't know if I remember, but I did put some specific names that we're gonna continue using, try to match them in our diagram. Okay. So remember the machine, it is going to be quite simple, and it is actually gonna be pretty much quite pneumatical. Sorry, quite pneumatic. Yes, there are gonna be motors for the conveyors, right? They're gonna be electrical stuff like the photo eyes, diffusion sensors, but the main things, the clamps, the stops, that's solenoid 1 or 2, and the main stamper, they're gonna be pneumatic. All right. So how do we do a pneumatic assembly? Pneumatical assembly, sorry. You can do that in different ways. There are different softwares, all right? You can use softwares that they are really prepared just for that. I know Festo, at least he has some software, which it was pretty good. I tried the trial, and in fact, it was, I forgot the name. I could look if somebody really wants to know. It was like a typical software that you put the valves, of course, and you just connect everything together, but you actually can try simulate somehow if really works or not, okay, in the diagram itself. That was a cool feature, but of course, you had to pay, and I couldn't get that one. I didn't have the money at the time. So after that, I tried other options. The main one I'm using typically at work or outside, it is going to be AutoCAD. Okay, it is a very famous software, probably you know. They have specific software that is called AutoCAD Electrical or Electric, I forgot. And that AutoCAD version, it really should be called AutoCAD Schematics, okay? Because you can do schematics for electrical stuff, but you can do also like pneumatics and hydraulics, or even PIA and ID, okay, piping too. And it's the one I'm starting to use. Before I was using straight AutoCAD until I could get that module or that electrical, AutoCAD electrical. And since then, I'm pretty much using that one. So in this case, I have something already almost prepared. All right. Things to say, yes. AutoCAD, the electrical, sorry. That one, it does have, in theory, it's all electrical. You can see wiring. This is the normal features, but then you have this schematic. That one is pretty much seems like for wires, right? But they have here in insert components, here they have pneumatic components, hydraulic components, and PNID. And for pneumatic, it has some. I mean, it doesn't have all the ones that you're gonna need, but it has some that could be interesting, from valves, meters, regulators, and we're gonna use pretty much almost all of them. However, there are going to be some ones that you're going to be missing. In that case, I used, it depends on you, but this is the ones I'm using. Let me see here. I'm using smc.eu, and then you're going to get a library with all these components for pneumatical schematics. You can see in the XF, okay? So you can just download them, and you can in fact put them in. And we're going to do that because some of the valves and stuff that I'm going to use today, I don't have them in the AutoCAD, but I do have them here, okay? The only thing that you're going to see is that you're going to have to scale them down a little bit compared with the other ones to match nicely, okay? So we're going to start with, remember, we want to pretty much do a diagram of this machine, okay? What does it have? Well, it has the two clamps, it has the two stops, and it has the main thruster, which is going to be a stamper. Okay, so that is a maximum of 5 solenoid valves. What more stuff do you have? Do you need? In this case, pretty much nothing. In other options, we're going to have different extra. And then before you start drawing, you're gonna decide first how many manifolds. Okay, because remember all the solenoid valves, you know for sure what it is. If not, check videos of exactly what is a solenoid valve. Okay, and the types that they have. There's like hundreds. We're gonna explain a little bit in this video, but I'm not gonna cover the solenoid valves today. I'm just gonna do the diagram. I'm gonna do a class video explaining the types of valves, and or at least a good amount of the types of valves, okay, and how are the symbols and everything, so you can kind of like understand when you're gonna do different diagrams. But today we're gonna just use an example. In this case, I'm thinking, I don't know, because I didn't do this design really. This is not something I did. This is something I pretty much was using this software. I didn't design a 3D of each one of them, so I don't know what is going to be the flow that I need. I don't know what is the pressure that I need. I didn't do any calculation for this. So we're going to go very generic, okay? How many, the solenoid valves, they are grouped by manifolds, okay? A manifold is going to be kind of like a block where the air is going to get in, and it's going to have different exits, each one for an valve, right? And we have to decide how many. First, manifolds, and second, how many valves per manifold. In this case, I have 5 cylinders, so I'm going to need only 5 solenoid valves. But you never know, okay? Right now, for example, one thing that could happen is that if I'm gonna have a lot of boxes coming, and things have big inertia, things have a lot of, this motor is having like, making these boxes go really fast, depending on the speed, I may need more than one clamp to support that one, okay? So no more than one box is gonna be here being pushed, and it could happen. In that case, what I'm thinking is, why don't I just leave one extra cylinder in the manifold as an spare, okay? It's not gonna be used right now, but if I need it for some reason, I could use it, right? If I'm sure I don't need it, I don't. If I think I could need it, just in case, I could just leave one, okay? I always, in fact, if not, I only make 5. We could always add another one, okay? But today, just as an example, I'm gonna add one spare just in case, and we're gonna have up to 6, okay? Also, we're thinking that maybe the machine is gonna require things here upstream, and we're gonna need another cylinder to do something. That's why I'm gonna use the spare, but I'm not sure. I'm gonna use the spare. So how many manifolds I'm gonna need? I could do 2 manifolds, one for the clamps and stops, and one for this and the spare. But it's kind of like odd having like 2 manifolds. We're gonna try to make it simple, you know. And 4 for a manifold is not too much. So you know what? I'm gonna do one only manifold to make things easy and cheap. And at the same time, I'm gonna put 6 solenoid valves in the manifold. More things that I need apart from solenoid valves? Not really. Okay, just to make things work. But as an objective, I need something extra. I need air to be flown somewhere. No, maybe I could, in case of this isn't a line, the only thing I could think about is just leave one quick release prepare, like a female one, so I could connect things that I need. For example, well, I want another machine to do things, just like a portable machine, and I need to connect in air. I always could use these machines to run these portable ones, okay? Just for like checking, testing, whatever you need. And we're gonna try to do that also. So we're gonna start with the diagram. Here is gonna be the main, this is gonna be the schematic, okay? This is gonna be, I'm using like a regular template. I'm really paying too much attention for that. Okay, I'm gonna use a regular sheet size. It's probably gonna be pretty much the entire schematic, okay? If you get if this is gonna get too big, or sorry, the template is gonna be too small, I could use a C size. I'm talking about ANSI in US. If you want to do the equivalent in Europe, you're gonna go with, for a C size is gonna be equivalent to an A2, and for a D size is gonna be equivalent to an A1. You can always go to an A0, but that is very big. So we're gonna start here with this symbol. I already put it there. This pre-match symbol is gonna be the symbol where the flow of the air is gonna be coming from. And something I forgot to mention is that, as always, we need to follow standards, right? In this case, because I'm in the US right now, I'm going to use their standards, okay? And in this case, I'm going to use that ANSI IY 32.10 for fluid power graphic symbols, okay? If you can get one, they pretty much explain everything, at least the most basic ones. You have solid lines, dash lines, you have dotted, you have center line for enclosures. You're gonna see how things they have to like jump, or you can do that. How lines connect using dots, or this other option. I like the dots on this one. And other options, you're gonna see here, for example, you get here the pneumatics. This is how it flows. Okay, if it's hydraulic, it has to be full with pneumatics. And then also anything, from quickly releases, vents, heaters. Here we got the filters, cylinders, valves. We will explain things using that. Okay, this is the standard, and we will put it because we want to know that everybody is going to read the diagram is going to use our standard or knows, so then they know that we're doing a good job and we communicate correctly. So we're going to start with that. We know the flow is going to go from here. I put this implant air, meaning that I'm taking the air from the plant, from the factory. Okay, you can put whatever. And we're going to start adding the most basic things that you're going to need. The most basic things you're going to need. Put the microphone here, sorry. Yes. The most basic things you're going to need, which are going to be the filter, regulator, and lubricator. Okay? Those are the most basic things. I will explain exactly what is each one of them in future videos with more details. But pretty much you need the filter to filter things, you need the regulator to regulate the pressure, okay? And you need the lubricator to lubricate, okay? To work better for the cylinders and for some components you're gonna have in the line. So in this case, you're gonna start, with the components. We're gonna see what do we have here in AutoCAD electrical. And we're gonna have filters. Whoa, right away. Which options we have? We have air dryer, out drain, manual drain, auto drain. These are the two options I would probably check. You get just generic filter, you get air filter. I don't know which one I'm gonna need right now, so I'm gonna use regular filter, which is gonna be that one. Whoop. And we're gonna get the component. We'll write things later on. Okay, so now we have a filter. We're gonna have, okay, I'm gonna show how they are. This will be the filter type, filter, pneumatic. Okay, this is a filter. Okay, this is the regulator. You get regulator and filter. Filter only fills particles. It drains through here. Could be manual or could just connected, and it could be how they called filter. Auto drain, I guess. Manual drain or auto drain. After that, we're gonna have the regulator. Okay, the regulator is that thing. Okay, with that gauge. Okay, there is where you control the pressure. Why do we use regulators? Because the pressure that you're gonna get, the pressure that you're gonna get from the plant, you don't know how much it is. Okay, and you want to know how much pressure you're getting. To know the cylinder, it is sizing the cylinder, sizing everything. You're gonna have pressure losses. You're gonna have a lot of calculations that we will do one day. In another video, I will explain how to do them. And you're gonna have a lot of calculations, and you want to know how much pressure. And you also want constant pressure. So yes, maybe you're gonna get it 100 psi, talking in US, coming from here, but or whatever pressure, but here you really say, like, you know what, here it sometimes gets 100, but sometimes it's going to be reducing between 100 and 90. Why I want constant? I don't want changing, because things are going to change. The cylinders, they're going to work faster or with more force. You don't know really, and you don't want these kind of like issues. You want to be constant, you want to know what is going on all the time. So I'm going to regulate that to less, to 80, for example, okay? But it's going to be constant because always here is going to have more than that. So then it's going to reduce to 80. If, for example, I'm getting to 175, if you put 80, there's going to be moments where this 75 is going to go through, and then you're going to have between 80 and 75. You don't want that. Then you have to drop that to 75. Okay? So apart from the regulator, you need a gauge with the regulator, okay? And that is going to be just a regular pressure gauge, okay? We're gonna do here, and we're gonna go from the dot here to here, and then I'm gonna be sure, do I have the stuff intersection? Whoop-oh. Here. Now, that is gonna be setting the pressure, and we're going to put in notes what pressure do we want, okay? That is something the engineer wants to know. And what more do we need? The lubricator, okay? Lubricate, we're going to need, I think it was in filters, filter, lubricator, here it is, bingo. Oh, what happened? Oh yeah, sorry, I have to repeat that. Filter, lubricator, here, delete that. Or gonna have to, I don't know what happened, no problem. We're gonna rotate that. Is facing, let me see, it's facing down, I think, but I want to confirm, forgot. I should maybe check. Is facing down. Let's see, do I have filter is facing up, sorry, my fault. Lubricator, sorry, filter. Lubricator is facing up. So we're gonna move that. Awesome. Put that. So now we have the most basic part of a pneumatic diagram. You're always gonna need that. If you don't put it, it's because you assume, or you're gonna design a part that already has this in other part of the machine. So you're just making a complex assembly, okay, with pneumatic systems, but that is going to be connected to the machine. Then, of course, the machine has this FRL, as they call, filter regulator lubricator, so you don't have to make it. But if you're going to do the entire machine, yes, somewhere you have to draw that. So this is the most basic part of one of those machines, okay, one of those pneumatic assemblies. And now we're gonna write just so things they're gonna get, things are gonna get documented. Reduce filter. I'm gonna use that type of blue. It's an odd blue. I'm gonna use that. We're gonna reduce that to 0.50. Oof, that is too small. Maybe 0.75. Much better. All right, so now we have our filter, which is going to be here. Okay, now we're going to have also our regulator, bingo, which is going to go down, and our lubricator. All right, so we have the three most common parts. Now, what comes next? I want to continue the pneumatic line, the air line, and here, pretty much, in our case, we don't really have nothing else than a manifold with all the solenoid valves, okay? As I said here, there is nothing really going on. If I want to do that extra line, I could do before or after. Doesn't matter really. In this case, you're going to do that before. If it's after, the pressure is going to be the one that you mark in the gauge. If it's before, it's going to be whatever pressure is coming, okay? Many times I see that before. And we're going to do a point. We don't have to, based on the standard, remember? We don't have to do the points if we want to connect lines, like here. But I think it is kind of like a little bit easier to see things if you're going to use that dot. Personally, I like that combination when they're going to be crossing. I don't want that every time. I don't need that. This is common sense. But now, just to make less confusing between that one and that one, I like this one and the dot. Okay? So we're going to use the dot. In this case, the schematics has its own dots. It's for really electrical components, but you know what? It works fine even for our case. So that is going to be the dot. Awesome. So we will do something here, but now we're going to really get focused in the main thing, which is going to be the manifold. So how am I going to do the manifold? Well, in this case, as I said, everything depends on what is going to be your type of valves you're going to use, what is going to be your types of cylinders you're going to use, so on. In this case, we're going to use for all of them, they're going to have two, the cylinder is going to be double. Means, depending on the air going in the back or the front, it's going to push, it's going to retract, or push forward, okay? Or extend, sorry. If you have a single, it has a spring, so you only push, you only retract or extend, and the spring is going to do the other. I'm going to use a regular both dual cylinder for all of these conditions, all these pistons or cylinders. I'm going to use dual. And I don't want to stop. I don't need the cylinders to stop in any position. I want to fully retract, fully extend. Okay? So what options do we have? I saw that we don't really have that one here. We don't. Here I have different valves. We have 3-way valves and we have 4-way valves. But I need a 5-2. So in this case, I'm going to have to come to the library that I said before. And here you're going to see these are the different type of valves, but these are like manual operated and air operated. I want solenoid valves. Okay, so they're going to be coming here. And we have 3-2, we have 5-2 and 5-3. I want a 5-2. Okay, that is perfect for a double dual cylinder. It's going to work retracting and extending. And it could have whatever you consider. So we're going to use a 5-2. You can have pilot operated valve or direct, and you can have single or double. Okay, I'm going to use a single, and I'm going to use, as I said, these things, it depends. Okay, in this case, I didn't do any calculation, so really I don't know yet what valves I need, but I won't do calculations for this example. For future ones, the mechanical part is going to have their own calculations, okay? The calculations, they have to be done by the mechanical engineer. He has to decide what valve is perfect for the flow, the pressure loss, and everything to go into the cylinder, so you have the force, but you also have the time that you want to extend these things, okay? So we will do that in future videos, but today we don't have that because I didn't really design this machine. It is already in the software. So I'm going to use for example, single pilot operator, okay? And that is going to be, we're going to download that, which I already did. Indeed. No, my mistake, projects, and we're going to have the pneumatic symbols. Okay, it's going to be here. I don't know which one is. It's going to be a 5-3. No, so yeah, it's going to be a 5-2, sorry, pilot operated double single. Okay, we're going to try that one. Let's see. So this is going to be the valve. Okay. These valves, they don't have that thing of normally open, normally close, because both options, they're closed or open depending on how you put that. Okay. We're going to copy that. I'm going to paste it here. Problem, you see the scale, it is huge, okay? If I'm not wrong, I think these ones, they were like around 20 the scale or 40 the scale, I forgot. So we're going to do 20 and then see. Whatever scale you're going to do, you're going to have to write it. So 1 divided to 20 by 20. Yes, I think it's going to be the perfection. Okay, so that is going to be the valve, okay? Whatever scale I do, I'm going to write. So I'm going to say scale, solenoid valve, SMC library equal to 1/20. Okay, and then we know that that is going to be the scale. So we don't have now different valves in the future. They're going to have one is 10, one is smaller. It's going to be odd. So now it depends. You want to face cylinders up or down. Typically, you're going to see examples where things are going to be facing. We're going to have any schematics here, like pneumatical schematics. Oops, capital letters, doesn't matter. Pneumatic schematic. It's going to be the cylinders up, typically, right? Doesn't matter. As far as I know, I didn't see anything in the standard telling me the opposite. I like pistons down. I guess that's odd. So we're gonna mirror that. Boom. Yes, okay. So now we have down. And yeah, but I don't want to mirror. Sorry, my mistake. I want to rotate. Okay, I want to rotate. So now they are awesome. And the only thing I want to mirror for sure are the numbers, because these numbers, they're not basic. Sometimes you're going to see letters like E, A, EB, EA, things like that. No, I'm going to rotate them back. Pick, awesome. I'm going to rotate the numbers back, and I'm going to do mirror them. So, bingo. And yes. So we're going to put them where they should go. Here, bingo. Okay, so we have the 1 point, 2 points, 3 points. That's not perfectly right, but that one really goes to here, the 3 goes to there, the 4 goes to here, the 2 goes to here. So we're going to put them closer. That 3 is going to go actually here. The 4 is good, but the 2 is going to go here. The positions of the lines, it doesn't matter. More things I want in the valve. Right now, this is telling me that this valve is a pilot valve. That's why it has here these things. Okay, which I don't have. In fact, mistake, my mistake. I didn't want that valve. I wanted that one. My mistake. So I'm gonna have to open, yes, because I want the spring. The spring means that instead of being like one or the other one, wherever the air is not, oh sorry, the electricity is not connecting or pushing the forcing the valve to do whatever, with the spring is gonna come back to its other position. So I'm gonna move it. Okay, now I'm gonna move the numbers back like we did before, if I can. Okay, and now we're gonna mirror. Awesome. I'm gonna mirror. Bingo. Yes. Mirroring and putting that there. Okay, well, remember, 1 goes here, 3 goes there, 2 goes here, 4 goes here, and we have the spring. We also have these 2 things. Okay, pretty much it's telling me that this is a pilot operated valve. Okay, and as I said, I don't want pilot. I'm gonna use as an example do I have this one? Okay, Pneumatics is a company and they have their own type of valves. I'm going to use an example, the last one I used, which is going to be the Mark 8 series. That is going to be the solenoid valve, and that is going to be the manifold. And you connect one with another one to make your manifold. Okay, so those ones are single. And you're going to say, how do you know they're single? Well, we're going to see that. Valve type, single direct solenoid spring return. Okay, and you have the double direct, we're going to use single. It's going to be an 82 whatever SA. For example, I'm just using an example. So it's going to be single. This one is single. And you're going to say, how is the double? So we have here a double. We're going to open that so you can see. C has solenoid in one side, solenoid in the other one. This is pretty much saying like it's a solenoid here and here. Okay, so it's in both sides. I don't want that. And I only have in the other side. Here, good. And I have the spring in the other one. And it says it's pilot, but this one we said it was direct, not pilot. So we're gonna delete those small square things that go away. We're gonna put that. Remember, if I put it on the other side, it's double, but I don't want. And we also wanna do, just because I feel like we're gonna do this extra symbol. Oh, wrong document. Which one? I'm gonna show you which one is going to be. This video could be long. Let me see. Ah, here it is. That. This symbol. Okay, that is the same thing. That means it's a pilot. Solenoid here, the pilot here, or the manual override. That is the manual, okay, and this is the manual. Okay, that means that you can connect also this solenoid valve manually. You can. So we're gonna do we can do everything together. So we have that, and now that is going to be here, and now that is going to go one. That is going to go here in one. Awesome. So now we have that thing. I would probably say that it is to awesome. The only thing that maybe I'm gonna get in a little bit closer. So now that it means solenoid with a spring return and is manual. Okay. We're gonna move that one to our drawing 3. Okay, and remember that is huge. We're gonna delete the previous one. We're gonna delete this residues. Awesome. It is huge. We're gonna scale to, remember, 1 divided by 20. That is gonna be the scale. I think it's a decent scale. And we're gonna put it here. Okay. So now, because we want to use this one, means it's a 5-3, 5 and 3-way. We're gonna have 3-way manifolds to use this type of valves. Okay. So right now we're gonna start making that manifold. We're gonna make a long. There's gonna be 11. In fact, I may do another 2. It's gonna be a long manifold with all these valves. Now we're gonna need add 1. It's gonna be 13. Okay. We're gonna do a big manifold. It's gonna be 1 inch. In this case, we're working in inches, and you're gonna say, why are you working in inches? Because I have the program in inches. I don't want to change it. Ooh, what the heck was that? Sorry. Do 1, and then we say we're gonna do 13. Awesome. Okay. So now each one is gonna go to one of these 3 numbers. We're gonna prepare that. And we're gonna have the middle one is gonna go into the middle, and for some reason keep disconnecting. Go away. Awesome. The middle is gonna go into the middle, and the other ones I don't really care. Right now, that one goes here, and that one goes here. Okay. Why? Because as you can see, the middle is the one that it is sending the air to the next, or the cylinder. and the air is coming here. Okay, these two ones, they're gonna be the exhaust lines of the manifold, and this one, since the air is coming here, is gonna be the intake. So right now, that one is not doing nothing. That one, it is sending the air here, and that one is sending the air from here, from the manifold to the solenoid valve. If now you manually or with the electricity, you connect that, it moves here. Now this one is still the main pressurized line. Now that one doesn't do nothing, which is that one, and now that one is the one that is going to exhaust all this air. Okay, awesome, works fine. Now this is not the only thing I want to do. Okay, things are going well, but I'm thinking, you know what? What typically we're gonna do, and I'm gonna show that. Well, no, I'm gonna show that right now. Some of the, yes, you have your main regulator, right? You have your main regulator, which is gonna be that one, regulator with the pressure that you want. But the problem is that sometimes, if the lines that are complex, okay, and in this case could be one of them, you also want a specific regulator for some of the cylinders. Why do we want that? To control the force that they're pushing against the items. So for example, I want to be sure that that cylinder is not going to be pushing too much pressure, or we're going to damage these boxes. The same thing for that one, and the same thing for this one. This one especially, the stamper has to stamp with a specific force that is not gonna damage the product. If they damage the product, we have issues, okay? So what we're gonna do is, in this case, those Mark 8, some of them, they could have, apart from the solenoid valve and the manifold, they could have that thing, okay? That thing pretty much you install on top of some of the valves. That is a regulator itself. You can see here, you have the gauge. You can see here, that is the wheel that you're going to use to regulate the air. So you can actually regulate the air that is going to be coming. That it is awesome. And you're going to personalize for the specific cylinder. So some of those ones, they're going to be like that. Some of the other ones, they're going to be different. And we have to know which one is the first. That is going to be solenoid 1, then 2, then 3, then 4, and then finally solenoid 5. So the order is going to be first the stop, then the clamp, then the stop, then the clamp, then the stamper. Okay? The stop doesn't need a regulator for sure. Okay? The only thing that you have to be sure is that you need a airflow control. Okay? To control that the flow of this thing doesn't go so fast. Okay? You don't want to go so fast that you can damage the cylinder. You want to go with a specific speed. To control that well, just in case so things are going too fast, we are gonna put some airflow control. You can put them in different areas. Many times they're gonna put them in the cylinder itself, just at the exit. Instead of putting fitting, you're gonna put that flow control. In this case, since this nice Mark 8, which I really like that type of pneumatics, it has already some of those. This one, it already have the option. I think it was in function, in mounting maybe. Manifold, speed control. See, I can already have a speed control in the manifold itself. To represent that, in a way, that is not a standard thing. Okay, that is going to be my own personal standard. Well, that I haven't seen in this standard, but I'm going to represent that as a flow control inside of the valve. We're going to see that we want meters out, not meters in. We will explain in future videos where is the difference. Typically, as you know, most of these airflow controls are going to be meters out. Okay, we're going to represent meters out, and we will explain this in another video in a class. What is the difference between meters out and meters in? So right now we're going to get, oh no, electrical, no, we're going to get pneumatic. And we're going to think about different type of valves, three-way valves, quick disconnect, manifolds, flow arrows, muffler, no, flow arrows, no, left Flow paths, filters, regulators, cylinders, motors, quick disconnect flow. What the heck is that? Miscellaneous maybe? Flow control. I guess that is what we want. Okay, I'm gonna get that. Awesome. What if I do explode? Bingo. Awesome. I'm gonna take that and I'm gonna move it here. The arrow too, forgot the arrow. That one, and I'm gonna take that. It's gonna go. I said everything. Awesome. I'm gonna delete the rest. Okay, so to represent that, we're gonna put the flow control, which you don't have to represent that because, as we said, it is not a standard thing. In fact, you don't have to represent. As soon as you put the part number, when they're gonna buy that, you can put it here. You can put the code, and then in the 15, you're gonna put 25. So you already have the speed control. So you don't have to really represent that. But for myself, I like to represent things. It's not a standard, my fault. But actually, we're gonna try to represent that like that. We're gonna put a flow control thing in the manifold itself. Once more, this is not a standard, okay? But in a way, it represents that the air that is gonna be coming out, meters out, is gonna be controlled somehow. You can control that with, I don't know, a small roller, a small wheel, or maybe a small handle, I don't know, or with a screwdriver. You can do a few things. But so this is gonna be the first one. It's gonna be the stop. Okay, awesome. Now we're gonna move that into the position that we want. Here, for example, that's gonna be one ring. And we're gonna do the first manifold area, okay? I'm gonna do the first manifold, which is going to be we're gonna do a little bit bigger. There, oh no, it has to be even bigger than that. We're gonna take it from here to here, okay? That is gonna be the enclosure. Remember, different options, enclosure, center line. We're gonna have to use a center line, which is going to be, let me see, in properties, type of line weight, it's gonna be hidden node, that one's gonna be center line. And we're gonna separate two lines. One is gonna be the everything. We wanna separate from there. Okay, well, that is fine. We're gonna separate from there. Line weight, the same, center line type. So now we separate two areas. That is gonna be the manifold itself. That is gonna be representing that black thing, which is gonna be the manifold. That is gonna be representing the valve. Okay? That is what I'm gonna do. Now we're gonna copy the next, okay? Now we're gonna check the distance between one second. Let me just pause that. Sorry, continuing. So we want to represent that. What the heck are we doing? Yes, we're gonna measure distance from here to here. Okay, that is gonna be okay, we're gonna try to round that a little bit. Plus that, it's gonna be rounding that to How much? 1006. Perfect. Yep. And the same thing from here to here. Okay, we're gonna probably move that one to 0.0122. Boom. Right, perfect. So I'm not really want this to measure that. 2.8 pretty much. So we can do that, array that 2.8 several times, but of course we have to know that now this next one, which is the solenoid 2, is going to have a regulator, so it's going to be a little bit different. So what I'm going to do is an array that, we're going to modify then later. I'm going to array this plus that plus that. I'm going to array not in rows, only 2 in that, and it's going to be 2.8, we said, pretty much. Bingo. But of course, I'm going to have to explode that. Awesome. And now we have to consider, remember that we need a regulator here. So we're going to get another regulator, schematics, another regulator, which is going to be the same type here. Awesome. I'm going to delete that. Okay. And now we're going to have to do the line, the main one, which is going to be that one, is going to have to go through the regulator first. So we are going to rotate that. Awesome. We're going to move it far away right now. We are going to move this one down a lot. Now we're going to put the regulator pretty much here. And now that one, okay, is the one that is going to go to the regulator. So we're going to have that. Awesome. That one is going to go to the regulator. That one is going to that one is going to go here. Okay, so now this one is going to go here. That one is going here. And now that one, which comes from the center, una here. Awesome. Perfect. So now the regulator comes. Of course, with the regulator, we need the gauge. Remember, we need the gauge. Meters, pressure, and it's gonna go here. Forget, if you press escape, it just deletes that. A little bit annoying. Here. Awesome. Done. Okay, so now we're gonna have the gauge ready. Perfect. So that is gonna mean pretty much that regulator that we have here installed in the valve. Okay, remember that is going to be the valve pretty much. Okay, that area is the valve, that enclosure is the manifold. The entire thing is the manifold plus the valve. So now we have that. We're gonna have to array these another time because we have, remember, we have stop, solenoid valve, and then a clamp, stop, clamp. So we have to repeat that. Instead of repeating slowly, we're going to just array. Same thing as always, 2, and then that one, 2.8 we said. Ooh, times 2. 2.8 times 2. Awesome. Okay, so we have that. And now, well, at the end, you know what? If I don't have a space in this drawing and I don't want to make things smaller, I'm going to, my fault, doesn't look really professional. I'm going to leave it with a 5th manifold, but not the 6th. Okay, we want to put the 6th, the spare. We can do that. Okay, you can see this is the original one that I made. I just finished. For example, here, this is what we're going to do pretty much at the end. And I have plenty space to use a bigger one, and I use a spare. As you can see, the spare, it is just the solenoid valve, but we don't have the cylinder just in case we need it. In this case, we're only going to make 5 because actually this only really has 5 solenoid valves. So if we want to add an extra, we can always add an extra. We have to explode that. Bingo. What extra? What extra? Yes, we're gonna need another one that is gonna be like this one. And we're gonna pretty much, oh no, sorry, my fault. The final one, this one, the stamper, you wanna control for sure. That one you wanna control the force. So we're gonna copy this one. We're gonna rate that one, and that. We're gonna rate that. It's gonna be 1, it's gonna be 2, and it's gonna be 2.8. Awesome. Now we're gonna do the explode thing. Explode. Awesome. This one here, and I want to go with 2.125 length of an inch. Awesome. And we're gonna do the same thing here. That one plus a little bit. That one plus a little bit. Okay. And this one, which is gonna be the manifold, is gonna go till the end. Okay. Let's try to move this just here to the left. Not that much here. Awesome. Perfect. So pretty much we have the manifold with all the components. Things that they are missing for sure, the dots. We're gonna have dots for anything, and I want to put them. Oh, what is that? Really again? Good. Problem is that if one fails, the rest they do too. That one, and that one. Okay. So we have the dots. I want to install the dots before I forget. Other option, maybe if I'm a little bit more intelligent, I just array everything after. But I like to see how it looks before I continue. So what we have pretty much solenoid going on. What we have to do, finish the cylinders here, but also the solenoid valve. The manifold. Things that we have to put in the manifold. These 2 lines, they are for exhausting. Okay, when they exhaust the air. Right now you can leave them like that. It's gonna blow the air out. And sometimes they do that to go really fast when you want to blow really fast. But, well, you're going to flow fast. I will explain some things in other time. But, well, you can go fast, or you can install a muffler. Okay, a muffler is like a silencer. It reduces the noise that the air makes when it leaves from a surface so small. So you have 3 options. You have different options. We're going to install that one, muffler. You know what? I'm gonna copy and paste here. We have that one here, but we also have this one here. Mirror. Yes. Mirror here. Okay, typical manifold like that, you want to have both ways where the air comes and it leaves. Okay, you want the air to leave, to go to the atmosphere as fast as possible. Okay, and this is a fast way, but at the same time, with that, you control the noise, which is annoying, I can tell you. What about the main one? The main one is where the air comes, it's gonna go, but you don't want it to leave. So what you're gonna install is a plug. Okay, what is a plug? It's just like a threaded plug, pretty much, that you put there with some Teflon tape or Teflon paste or something, so the air doesn't leak through. And as far as I know, in miscellaneous, it had a plug here. Awesome. Here, this is the symbol for a plug. Okay, based on the ANSI. Oh, sometimes it does that. It is a little bit annoying, but it's fine. Control easily. All right. So this is gonna be our manifold. We have to continue. When I finished, this is getting closer to an hour. We almost don't have space, so I'm gonna move everything up. Move everything up. Typically, or you scale things down, or at the minimum, you're gonna start needing a big size drawing. And this is a C, which is not small. This is equivalent to an A2, which is not small. Okay, but or you use an A1 when things get a little bit complicated, or you're gonna have to scale down a little bit. Of course, when you're gonna print in full size, things are gonna be seen really well. What things are missing? Well, of course, the cylinders. Okay, the cylinders are missing, and a few things more probably. So what are we gonna do with the cylinders? The cylinders, what side you want them to face? I want all of them to be retracted when they are like in normal position. They retract, and this one is retract. Sometimes you want them extended, okay? And we will see that maybe in future tutorials and future designs. But in this case, all of them, they're gonna be retract. So how we're gonna do that? Since that one is the one that is gonna put the air, I want that to be in the front side of the cylinder, so the cylinder is gonna face left. How are we gonna do that? Now we're gonna cylinders here. We're gonna have these options here in the schematics. Cushion, cylinder extended, and retracted. We wanna retract it. You get double rod also, but we want regular and retracted. Okay, and that is gonna have to move. As always, 270. And this one I'm gonna make direct. This one here, cylinder is gonna be here, and then we have the other one coming from here to here to here. Okay, so that would be the cylinder. Remember that this is not in a scale at all, as you can see, so it doesn't matter. That air is gonna be flowing here, and it's gonna be pushing in this area. Okay, that pressurized air, and this one is not pressurized because it's leaving, is gonna force the air, the cylinder, to be retracted. Okay, now that plus that plus that, we are gonna array how many times? Now 5 at a distance of, if I'm not wrong, 2.8. Okay, awesome. But we're gonna explode some of them like that one. I don't want to go that far. Some like this one here, and the same thing here. here, here. That one's gonna come here. That one there, and the final one. So now we have the cylinders going to wherever they have to go. Okay, pretty much the main thing is finished. The symbols are finished. Well, we have that one left. Do we have schematics? We're gonna see. We have schematics for a quick release, quick disconnects. Also awesome. We're gonna do that. The open one disconnected is gonna be that one. Whatever, we're gonna explode anyway. Explode, boom, awesome. And we're gonna only use that side. That I understand that is really the female side. Move here. That one is gonna go. And I wanna rotate that thing facing now. Awesome. You kidding me? What the heck is that? That is gonna face like that, and I want that to be begin here. Okay, that is what I was explaining. That you can just connect other device, other machine, or like a portable something, and you can connect it here easily. You can still use in the air even if the machine doesn't work. And now we have that. Things that we want to add. Oh, forgot. Something that pretty much always you want to add. Okay. And we're going to move that to the right as much maximum as I can. Here, pretty much. You want a manual valve. Okay. Pretty much go, no go valve. Okay. You want to, as a security in pretty much any machine, install a go, no go, which is not any of these cases. I'm going to have to go again to the library. I want a go, no go valve. Okay. Pretty much. Manual valve, go, no go. Okay. With a lever. That is a lever. Go, no go valve. Okay. And to be honest, I don't even want that thing. Normally open. Is gonna be this one. Normally close. Push button, no. Foot pedal, no. Twist selector. It is a twist selector, really. Regulator is a twist selector. Is a twist selector. Twist selector valve. Nah, that. Well, I mean, it's what I'm looking is like a manual typical valve that you can open in 2 positions. I mean, you can do that, but it's not what I was looking. I was thinking in a regular just valve, manual valve. As we said, let me check in the standard. For the valves, let me see, lever. That is the one I guess I want. I want to check exactly what is a lever valve. Yes, this is the one I'm looking, a lever, perfect. So a lever valve is gonna be that symbol. That's SMC, that one is very similar. Yeah, it's that one just in the opposite side. I don't know why they call that twist selector, because here I don't see twist selector at all. This is manual, just as a use as a general symbol without indicating the specific type. But no, I want that. Okay, and I want it without the spring. I just want a regular one, so we're gonna copy that. Is to foot pedal. No, sorry, foot pedal, twist selector. So I want to twist hand to mechanical full mechanical basic twist. So we're gonna get that one. And we're gonna delete that. And what the heck is that? Go. I want a manual twist selector or lever. We're gonna copy that. We're gonna paste it. Huge, no problem. We're gonna divide it by 20. Scale 1 divided by 20. Awesome. That valve is kind of like a safety valve. Okay, if this is not connected, things ain't gonna work. Okay, so what I'm gonna do is rotate this whole thing 90 degrees. I'm gonna see if I can fit that somehow. And this is normally closed. Pretty much always you want it normally closed as a safety. Okay, perfect. Okay, the planter should go here. So this is, you want that, okay? You freaking want that. You want that. I'm gonna move. This can go here. Sorry. You want always to have a safety manual valve, okay? You just connect the lever. Everything fine. Something happens, you just disconnect. And right, it normally closed, okay? Normally open is when you connect. So pretty much the symbols are finished. Yes, so now we have to just put some nomenclature just to make things a little bit understandable. So you have the filter, regulator, lubricator. I have the implant air, and we have here now. I'm gonna write a few things more. I'm using the blue for identify, so that is gonna be quick, capitals, quick, disconnect, fitting, okay. There we're gonna have the manual valve or safety valve or on-off valve. Awesome. Mufflers, you have to put nothing, so freaking mufflers, the black the same. Now it's gonna be the valve. Okay, so these are the main things, but now we're gonna go with the manifold. I wanna have each one of the stages. I'm gonna use the same. Oof, I'm gonna make it a little bit bigger. It's gonna be CO2. They call that, for example, here, if I'm not wrong, pneumatics. Valve stations. We're gonna call that a station. We're gonna go station 1, station number 1. And now we're gonna place it more or less here, more or less. I mean, it doesn't have to be perfect. We're gonna array. It's always 1. This is gonna have 5, and it's gonna be 0.8. Awesome. We're gonna explode. So now we're gonna write station 2, station 3, station 4, and station 5. All right. Extra things we want to add. We want to put nomenclature of things with models. Okay, so we can know right away what model is, but at the same time, we're going to put where everything goes. So we're going to do the same thing as here, and that is going to be a stop entry. Okay, so we're going to do that more or less center, and we're going to array again. Color. Yes, array 2, 1, 5, then 2.8. Remember, explode. That one is gonna be clamp entry. That one is gonna be stop in position, right? Stop in position. This is gonna be, joder, ¿qué le pasa a esto? Clamp in position, and finally stamper. Okay, so we know that's gonna have whoever is gonna assemble this thing, which one is which one. Now we're gonna put here something similar like that. We're gonna put here the model of cylinder. So it's gonna be cylinder part number. Okay, pretty much. That I'm gonna rate for sure. A little bit lower. That I'm gonna array 1, 5. Okay, so we're gonna have the Festo, Bimba, whatever company you are using, McMaster, whatever company you're gonna use, or whatever supplier, you're gonna put here the part number. Okay, and then we're gonna do the same thing in a way here with the valve. So it's gonna be valve part number. Okay, we're gonna do the same thing here. We're gonna put the same thing here, 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 here. Okay, and it has a specific regulator part number. Okay, I don't know right now which one is because I didn't do that one. I don't know what regulator I'm gonna use, but here's what I will use. I will put mine. More stuff I'm gonna put probably the valve valve on off part number, this thing part number, this thing part number, this thing part number. If this letter is too big, just make it small. Here is small, so it is easy to understand. And the last thing I'm gonna do, at least in this one, is going to be in a different color. Use the same letter in this case, and it's only gonna be in that one. Here, no, in fact, it's gonna go here. Oh, forgot. Here, what letter I wanna use that? Yes, the electrical stuff. I'm gonna change the color. Okay, for future drawings, I'm gonna use magenta. Oops. And here I'm gonna put things, all the electrical stuff. In this case, the magnetic sensor 1, because I know that stamper, it has a sensor. And I'm gonna put the sensor of the rest of the stuff, okay, which is gonna be the same color here, and I'm gonna put here sol 1, okay, sol 2, sol 3, sol 4, sol 5, okay. Four, 3, 2, okay, 1, 2, 3, 4, 5, which are those. Solenoid 1, 2, 3, 4, and then 5. I'm trying to use the same names, so right now these guys know that that one, or the electrical engineer knows that solenoid 1 is that one, solenoid 2 is that one, 3, 4, 5, and also knows that the 5, it has an MSR 1. For both the electrical engineer but also the mechanics, they're gonna install the pneumatic system. They're gonna know that this one is gonna have a magnetic sensor. Okay, sometimes I didn't see that in the standard. As far as I've seen, I didn't see that. But in the SMC, library, it does have this thing. It says, oh, what is it at? Here it has two. It has like these two dual. I don't know what is that. Ceiling rods or whatever. We're gonna have the bore of the cylinder pretty much is magnetic. Okay, without a magnet, the normal one. As I said, I didn't see that in the standard at all. I didn't see in these ones, cushions, whatever. I didn't see that magnetic thing, so I'm not gonna put it. But hey, you represent that with the MSR. If not, and also the cylinder is gonna have the part number with the magnetic one. If not, if you really want, we're gonna put 2, just representing that it's magnetic. So pretty much everything is done. I think that should be enough. As I said, I made my own one, which is similar. I forgot one thing. Here I put a spare valve, not really needed for this case. Pretty much everything is the same. I forgot to put in electrical stuff. And I put this pneumatic manifold assembly, and typically I put the part number of the whole thing here to represent that. Okay. Things that I didn't do that you don't have to, but I like. I put colors in the wiring or in the and the airlines to show things. Okay, so the manifold, I'm gonna put it. The things in the manifold are gonna be white, but the manifold itself, for example, so you know, it is going to be a different color. Okay, as I said, this is not needed, but maybe it could help. So we're gonna do that. We're gonna do properties, and the line is gonna be that color. Okay, so I know now the manifold is gonna be that color, and I'm gonna say, for example, you can put it in or out, reference or notes, reference. I'm gonna put reference, 2 points, and I'm gonna do a freaking line. I'm gonna do, yeah, that line is gonna be a manifold. That is gonna be manifold. Enclosure. Okay, and that is gonna be the same freaking type of dash and the same color. See? For something. Now, more things I want to add. Colors for the airlines. In this case, I'm only gonna use 2. So I know that, and that, and that, and that is gonna be this like metal piping, you know. Then I'm gonna use a specific color, green. Okay, and these, and these, that one, that one. Sometimes I look at it, it's annoying as hell. One. And that one, I'm gonna put them red, okay? And I'm gonna say, what does it mean? I'm gonna explain that, for example. So the colors is kind of like a color code for the type of airlines. Okay, so now we're gonna do that. 1, and it's gonna be 4. 1, it's gonna be 4. Okay. That one is gonna be, joder, macho. This is freaking annoying. That one is gonna be, in this case, remember we're in the US, or I am in the US, half, something like that. Stack, thank you. ID, for example, or OD, pipe, tubing. for example. And that one is going to be quarter 1/4 stack OD tubing. Okay, so now I know that if it's green, it's the pipe. Green is the pipe. The red is gonna be that plastic tubing. Okay, we can even put the part number of each one of them. Okay, so as you can see here, we have things. We know that one is tubing, that one is piping. And you're gonna say, what about this? Well, this is the manifold. As you can see, it comes from here, the manifold. So the manifold, as you can see, in my case, the one I'm using, the manifold is gonna do the air through inside, so it's not gonna have tubing, external tubing. It's gonna have its own thing. So that's why I put in that way. That is something that I personally like. You can now play with the layers. And you can say, well, you know what? That blue stuff, properties. See, it's gonna take a little bit. So we have like 50 millions. Freeze, lock. This is the new AutoCAD. I haven't really used it a lot before. Delete, change to current layer. So if I do that, and I'm gonna do, I was doing in the 16, it was similar, but not the same. It was the 13. New layer. Oh, here it is. So I'm gonna put, for example, here nomenclature. Okay, and that is going to be the same freaking color, which is gonna be that one. Okay, so now my fault that all these, and I will put it in more stuff, is gonna go to nomenclature. Okay, so now if I get nomenclature and I wanna, and so I layer off on, I'm gonna do that with all of them. Okay, with different options. You wanna do the colors, you wanna do different things, the part numbers you show or not. That it depends. You can play with. So well, you can disconnect or not, depending on who you want to print it for or whatever. Okay, so this would be for this case. Okay, we just finished an hour and 23 minutes. This would be for that case quite easy, I have to say, compared with others. A machine for the pneumatical diagram. Okay, so this is it. Not too complex. We have the stations. We have the main stuff, mechanic above. We need it. Okay, as a safety. The plug that we're gonna use for other things that they're not really for this machine. Okay, but they're gonna be needed. The filter, regulator, lubricator, basic. Now we can put nodes. We can do nodes, capitals, of course. And you can do, for example, a what I was saying. Oh yes, a main regulator set to, in this case, USA. Remember, 80 psi's, for example. Okay, so we can do that. Nodes first, regulator set to 80 psi's. So you set here, you can even put here a number with a different layer. And so those are basic. These things are basic. Maybe that one not, These other ones are basic. We need that on-off valve, and we need manual valve, and we need the filter regulator and lubricator. And now we have the main thing, or the objective for this machine, which is going to have these different solenoid valves. Here are some with regulators to control the force, some not needed to control each one of these cylinders. Okay, so I'm going to save that. Pneumatic symbols, no. I'm going to do in pneumatic template now. I'm going to do tutorial 1, which is going to be in assembly. I'm going to save it later. YouTube channel, awesome. Tutorial 1, here it is. And I'm going to override the pneumatic in the previous one. I'm going to do another one just in case. Okay. Pneumatical diagram. I'm probably going to delete the schematic. Save it as 13 just in case. Okay. You're going to save it, so if somebody wants it, I can always print it for him. You can print it in black and white. That's why I put these things out. You won't see the colors. Or you can print it in colors and you can see which one goes. Okay, that is to say, it's really nice, so they know what are different ones. And you can put, for example, different code colors for each one of the diameters of the piping or tubing, so somebody could know right away which ones to go. Okay, that helps to set these things. Okay, so thank you for watching today. The next video is going to be something similar, but we're going to do actually the electrical diagrams of this machine. Okay, not too big of a deal neither, but it is a little bit more complex probably than this schematic. We don't have, as we know, a lot of electrical stuff, 2 motors, but each one of these solenoid valves, they're gonna be moved by the PLC. Okay, so yes, we need a diagrams for the motors as well. And then the next one, sorry, we will do the coding, the programming for the machine, and then we will run it. Okay, right now the machine is stopped, it's waiting, and we are doing all the diagrams so they can start working in the pneumatics, electronics, electrical diagrams, wiring, and the programming, so the machine is going to start working ASAP.